Number 8 has a soccer ball kicked at an angle, 30 degrees, level ground, and hits the ground 2 seconds later, 2.6 seconds later. So we'll draw a real quick sketch here. Okay, so delta t, 2.6 seconds. We know this initial velocity was at an angle of 30 degrees. Not much information, but we want to determine how far horizontally, we'll call that distance x, did it travel. Okay, this is a trajectory type projectile motion problem. We had the trajectory equation. If we knew information about the initial velocity, the x and y positions, and the angle, we could calculate one of those values. We don't know either the velocity or this x. We've got two unknowns here, so we'll probably need to work this a different way, and that is looking at the x and y directions independently. So use our standard coordinate system with the ball at the origin, x to the right, y going up. We can work out some information here. If we can find the initial the initial velocity, then we can work from that. The key here is we know information about the y direction. We know it starts and ends at the same height. We know how long it's in the air. So let's write out a y equation. Y equals y0 plus vy0 times t plus 1/2 acceleration y t squared. The only thing we don't know in this equation is our vy0. Once we know that, we can use that in the angle to relate it to vx0 or v0. Alright, so we'll have 0 is equal to 0 plus vy0 times 2.6 plus 1/2 minus, this problem doesn't tell us what units to work in, so we just have, it says, sorry, it does say meters, so we're going to use a minus 9.81. Okay, times our time squared. So we'll solve for vy0 and get that value. That looks like it's going to be 0.5 times 9.81 times 2.6 squared divided by 2.6. Okay, I guess I could have also used, no, I couldn't do that, sorry. Don't get ahead of myself. Vy0, 12.753 meters per second. It's just second. Okay, oops. Okay, I can work a couple different ways from that, but I know that this velocity vector is at 30 degrees, and it's made up of components Vy and Vx. Alright, so I can get Vx over, let me write it this way. I can work with this triangle directly and say that tangent of 30 is equal to Vy over Vx. I can get Vx is equal to Vy over tangent 30, which is equal to 22.09, we'll call it. Okay, and then I can work with the x direction, which has constant velocity. That's Vx0. That's 0, that's 0. Times t. But that's 0 for ignoring air resistance. So this is just going to be 0 plus 22.09 times 2.6. Or 57.4 meters. Again, the key here is we did have to work in two separate directions. Have a choice of equations to use there. This is probably one of the more straightforward ways.